Right? Good to see you. Any business questions, assignments, anything weird happening? Somebody, I don't know who, I think it was it you? Yeah. Emailed me about a question on the quiz that was kind of jacked up. If anybody else encountered that problem, let me know. There was two right answers, and that's unfortunate. But I inherited these quizzes from whoever came before me. So if you guys don't tell me there's something wrong, I might not catch it. What else? Anybody see the comet? Yeah, pretty cool. I went last night with my wife. Uh, took some pictures. You guys still have a couple days to see this thing if you want. Comets are kind of rare. I think this one won't be back for a little while, something like 80,000 years or something like that. So, this is your chance. You can see it right after sunset, which is cool. It's if you guys know how to find Venus, which is the one planet you can probably find really easily. It's usually the brightest one. It's going to be right off to the side of Venus, and it's only visible for maybe an hour after sunset or something. But it's off in the west. So, you had a question? Yeah. Well, for where I lived, so I live kind of in a valley, so I had to climb up on the ridge to see it, which was kind of fun, anyways. But you guys just need a good western view, and I don't know what it's like around here. I live further closer to Grants Pass, so if you need a good view of the sunset, basically wherever that is for you guys, is there something like that around here? It's kind of you guys are kind of what? I get so disoriented because of the five. You guys facing?
Actually, it's not great, just because like you have the hills just west of us.
I see. I see.
We went up to, I mean, you can see it fine from Medford, even with the light pollution.
Really? Wow. All right. It's worth doing. It's pretty cool. We're not really doing comments today. We have like a piece of a lecture devoted to those later, but comments are kind of weird. They have two tails on them, which is kind of bizarre. And this one's particularly weird too. You guys, I don't know if you can see this right now. Let me see if I can turn this down a tiny bit. Um, the other tail for this one's actually kind of down at the bottom of it, which is pretty bizarre. So one of the tails of the comets always points directly away from the sun. The solar wind, which we'll talk about next semester, is just blowing these things apart. And so you have this kind of ionized, usually this bright tail. There's another tail that traces out the path where they've come from. So it's kind of like the wake of the ship, which is just a bunch of debris and stuff. So actually the wake one is kind of pointed downward. So if you were at a different vantage point, you would see it differently. So I think if you're on the other side of the Earth, it might not be pointing the same way for you. This is going to play, probably not. But there's you can kind of see the dusty one tailing off the side of this, and it kind of leaves a nice trail behind it. So yeah, comets are crazy. We'll deal more with them. Um, this one's supposed to maybe not even stay in the solar system. So people are debating whether this is going to work out or not. It has a pretty bizarre inclination. So it's at 139 degrees to the ecliptic. So as you can see, it kind of comes in not only at an angle, but it actually punches out and lifts up as it goes. So it's very, very bizarre. It seems to kind of act like it's not even part of our solar system, which is really interesting. And then, of course, comets are cool too because they only start making that tail when they get close to the sun, right? So we'll look at some close-up pictures because NASA actually sent a little orbiter at some point to go and check out one of these things, and we got some really cool pictures. We'll get to that. Does anybody have thoughts about climate? I have very little more to say about it. Thoughts? I want to hear from you guys. Are you guys worried about the climate? Yes. What does it mean to you to be worried about it? Oh God, that's the feeling. Yeah. I mean, I tell you what, there's a lot of things that are really sketchy right now about the world in that sense of environmental catastrophes. I think I mentioned the coral that I was checking out recently. But I think like the last thing that I just want to drive home with you guys is there's a lot of stuff out there that's really gnarly that your generation, subsequent generations are gonna have to pay attention to. There's like thousands of chemicals that aren't really being policed, right? and we can get like target fixated on one molecule, right? Which in the last 10, 15 years has been this carbon dioxide molecule. Carbon dioxide, I pointed out to you guys, it's a very small percentage of the atmosphere. It's an inert molecule. The plants love it. It's never been more green on Earth today. I worry, and that is the last little like proselytizing I'll do, that we get target fixated on this molecule at the expense of thousands of other molecules. Like I went for a run the other day, and like this was just the scene on my street, right? It's like, what the heck is this stuff, right? This is like coming out of people's cars or something. I have no idea, but where do you think that stuff's going? It's going into the water tables. It's going into people's wells, right? We're all on wells where I live. So like there's a lot of stuff, and these things, you go and have like your well tested, they're not even looking for this stuff, right? So there's a lot of things to be concerned about, and we have some slight danger of getting over fixated on one molecule at the expense of everything else. And that's the last thing I'm going to say about that. Thoughts? Anybody? Yes, please.
It's, I think, like to play the fun, like philosophical moral question of it all, like how we could do anything better. It's like wondering, especially like as, broke college students, how like, what would you like paying attention to it would be like a good thing, like even to like the other things we're thinking about when it comes to pollution, but like how realistically could like we make a considerable contribution to reducing climate change and pollution.
Yeah, it's something worth pondering. It's something worth talking amongst yourselves about. I mean, I think that the concept climate change, like, it really has a backbone that's really like pro future and like really looking towards the human project. Like the idea is like we should take care of our backyard, basically, right? Which is a beautiful idea, and I'm 100% behind it. I just worry that getting target fixated on like certain things at the expense of other things is really bad. Um, this like the idea like California is like we're gonna have all EVs by 2030. Do they have any plan for how to power them other than coal burning factories? Right? It's like the second, third order thinking that you have to really develop in yourself because, you know, it's like uh, it's like curing AIDS with a shot of cancer. Like it's not a good idea in the long run, right? So I think that we all like that's the one thing I'm trying to do here with this class in general is like get you guys to think a little bit beyond the textbook, like really question a lot of the assumptions that go into these things because just taking things on their face value is I think one of the more dangerous outlooks for the future. And like ideally, you guys are fortunate enough to come to college. College is a great place for you to try on really to be skeptical of the things you're learning. Yeah, that's crazy, but like it's a good idea. Um, we can with this idea of target fixation is really interesting. I think I mentioned I don't know if I told you guys in class, but like to read. I was reading for a while about airplane disasters, and like one of the biggest causes of airline disasters before they developed this kind of warning system was people just flying into the ground, like completely controlled flight into the ground, because they get fixated on some discussion they're having in the cabin or like some light that's going off that's insignificant or whatever, right? This target fixation where you ignore everything else and some disaster happens. And so I see little tastes of that with the climate discussion, which makes me a little nervous. In terms of like what we can do about it, I mean, a good place to start is just paying attention to the products that you're buying. Like we live in this market-based economy. Like one of the biggest ways you vote is not at the polls, but like what the stuff is you buy, right? Like take a look at the stuff you're buying, like if think twice before you like I have these annoying anybody ever deal with blackberry bushes on their property before? My God, right? These things are so like I literally develop rage when I'm like dealing with these things because they're stabbing me and I'm just but you go and read about how to deal with them on the internet, everybody's like just throw Roundup on them, right? And it's like, well, okay. And people are like, well, the Roundup will dry up, like it's gonna get soaked into the roots, it's fine. Well, where do you think that stuff ends up eventually, right? It's like it's definitely going to go into the water tables eventually. It's going to end up in your food. It's gonna end up in your water. It's not a good, and if it's not in yours, it's going to be in your neighbors or somebody else, right? So it's like there's all these tiny little decisions that we make when we go to the grocery store and we buy products, we buy cleaning products, we buy whatever. Like if you can't, pronounce the stuff on the back of the bottle, like don't buy it or study it a little bit. Like, just Google it. What's up?
Um,
Yes.
one, there was a graph showed last class that was something about like how throughout history,
Yes.
where we are in climate isn't actually that.
This guy, maybe.
So it kind of made me start thinking, and I don't want you to like take this as like too devil's advocate.
Oh, please,
If
please.
everything in the solar system kind of like adheres to a groove, right? Like the planets have their orbit, and like there's the seasons, and like everything has this little like
Rhythm.
rhythm.
Yeah.
Is not like it seems like it would be pretty hard to like force humans to not do this thing that we seem to be so like programmed to do. Like we're so that's like just something that we all do, I guess.
Like we get in a groove or whatever,
Yeah.
right?
Like that's also part of our like story.
I think it is part of our modern story to some extent. I don't think that it's always been the case. And this is something I'm going to pick on really hard today, is this narrative that we all learned in middle school that, you know, we started off as kind of like ape-like, you know, chimps and little tribes, and then we became more sophisticated and we developed this technological civilization that's like this apex of human progress. I think that's a little misguided. I think people have actually found ways to center their values in the past in ways that suggest that they weren't just unthinking or unconsidering or not philosophical. They literally made decisions about how they wanted to live their lives differently as a whole, and they enforced that amongst one another. And so the groove that they set themselves in was perhaps different than the one that we accept today, where you go to the grocery store and you're like, oh, they sell it on the shelf, it's got to be good, it can't be that bad for me, right? It's like, yeah, well, they sell cigarettes and, you know, lottery tickets too.
I think that is such a good point to bring up, and I think that that really, what that reminds me of a lot is the theory that maybe there were other like human races or civilizations that have appeared before and then like drive themselves into extinction. And I think that it's interesting that I think the argument isn't that like the world will be destroyed and all like will end. I think it's that humans will kill off themselves and then like life will continue on is what I think will end up.
Yeah, that's probably happened many. Well, I can tell you for a fact that that's happened to every civilization that's ever come before us. And it's really interesting because some of these civilizations were super powerful, like super badass, right? And they're gone. It didn't work out for them. And it's like when you start to deconstruct the reasons why it didn't work out for them, it's these compounding factors that are myriad and all these little tiny cracks, right, in the wall. People, you know, failing to take care of their water supplies, people being oppressive, their governments not really representing the interests of the people. I mean, ancient Maya is a really interesting example because has anybody been down to like Mexico or Guatemala and seen some of these places? They're constantly digging these things out of the jungle. It's just covered in cities basically down there. And it's really weird because it seems like at some points there wasn't a disease, there wasn't like some huge pandemic, there wasn't a big war, but people just left the cities. Over about 100 years, they just decided, you know what, the heck with this, right? It seems like the governments that were in place then became, they were overly concentrating the wealth, right? So they were keeping too much. People were kind of starving or not doing well. And instead of there being some giant revolution or anything, people were just like, you know what, I'm just going to go back to the jungle and start a farm. This is stupid. And that's how the Mayan civilization collapsed. It wasn't this big bang. It was just kind of this, I don't want to do this anymore. So there's a lot of different ways that civilizations can go away and new civilizations come up in their place. And of course, there was other cities, like the Aztecs rose to prominence, right, a few hundred kilometers away. It wasn't like the end of the world, but definitely the world changed for those people in a way that was unidirectional. It didn't circle back. So, yeah, I think civilizations come and go, but that's really the danger. It's like you guys look around at this world. It's an awesome world. Like you can go down to CVS and get medicine. You can go to the hospital if you break your leg. You can go get groceries at I don't know where you guys go, Safeway or whatever. Right? That's really cool and nice, and I think we would all like to see that continue, right? And so the danger, I don't think, so much with a lot of this stuff is not so much we're going to go extinct, right? I mean, maybe we'll get hit by an asteroid or something, but probably not. Like the danger is really like, can we keep this thing working for us as human beings? And so that's the real challenge, I think. Thoughts, questions? Yes, please.
The planet warming leads to environmental problems, but there's also, pollution and stuff. I feel like it's two separate things.
Right.
Like, which one do you think is a bigger problem?
The pollution by a long, long, long shot. So I guess that's my point here is like, and I don't want to get in trouble here. I'm not like trying to deny global warming or something like that. That's not the point. The point is that look at the past, right? The Earth has gone through enormous temperature variations. In fact, it's been much warmer in the past than it is today, right? So we could still increase our average temperature by like 10 degrees, right? And we would still be within the range of what's happened in the past without any humans having anything to do with anything, right? As far as if we take mainstream archaeology to be true, there wasn't humans doing anything back then, right? And it was very hot still during these natural cycles. So, there's two ways to approach this. One is like, okay, and this is the one that we start to see a lot of today is people like, all right, we have to like defeat the warming, right? We have to beat it somehow. But I think that that's like not only like a little bit Sisyphean, like it's a very like difficult thing to pull off in reality. It also sort of undermines what I think is a better approach for everything you do in life, which is like, how do I adapt to this situation in a way that's going to work out, right? Like the Dutch, for instance, right? I don't know if you guys know this, but like Amsterdam's like underwater, right? It's been underwater for 1,000 years, but it's a perfectly healthy working city, right? There's no reason for that we can't actually meet the changing Earth. And it looks like the Earth's going to keep changing, right? The climate's going to keep changing no matter what happens. Even if we go to zero emissions, no CO2 output, we kill all the cows so they're not putting methane out, like whatever, we go completely nuts and stop any contribution of humanity to it. It's still going to change all the time. And the reason for that is very obscure and difficult, which is kind of where I wanted to move next. Like, why is it doing this? This is pretty wild. And the explanations are not super great, but there is a feedback cycle of some sort, and it essentially has to do with the idea that once you get those ice caps melting considerably, or let's say once the ice caps grow considerably, then they start to reflect sunlight back out more, right? Because they're shiny, they're white. And so you get this feedback, right, where you're amplifying the cooling effect the bigger those ice caps get, and vice versa, as they shrink, you're amplifying the warming effect. And so you get these periodic oscillations as a result of it. So, like, to answer your question, I think that, I mean, it's just my personal opinion, but I'm much more worried about us poisoning ourselves and making ourselves less effective at meeting the demands of things like changing climate or changing economic conditions on Earth or AI or whatever the heck it is you're worried about. I'm much more worried about us poisoning ourselves and not being able to rise to meet those problems as they appear. Because I think like being adaptive animals is really what humans are all about. We've been through crazy stuff in the past before and somehow come through it. Yeah.
I think the argument is like, in the past, it happened over a very long period of time. It's like everything on top of that, it's not going to be fast.
I mean, it's pretty fast how those changes happen. It's kind of a spike in some sense.
Because it's like really zoomed down. Like those changes have happened over many thousands of years.
Yeah, but if you look at our temperature profile today, it's actually quite stable. It's quite a flat line even compared to the past. I guess if we were looking at the past, we should expect it to start cooling, according to this. And so if it's not going to cool in the next, 1,000 years, then maybe we're looking at something completely different. Yeah.
So right now, the cycles in Earth that we notice, those are because of changes in the Earth, like tilt. So what is causing these longer cycles?
Yeah, that's a huge question, actually. So
That's what I was going to bring up.
the axial tilt, changes in eccentricity, these other ones aren't as important. So there's a guy named Milankovitch who came up with this idea that if he overlaid all of these different cycles, he could
Yeah.
in some way predict the periodicity of these climate changes. It's kind of true, but there's huge problems with it as well. You don't actually end up with this 100,000 year cycle. You end up with alternating 95 and 125,000 year cycles. This might be true. There also might be factors that we don't understand, but I think that the one that's easiest to understand is that if you do have a little bit of cooling or warming over a long enough period of time, you get feedback as a result of the change in the reflectivity of the polar caps.
So it kind of just gets on a roll and then
Exactly.
slowly.
Exactly. It's kind of like you ever you have kids?
Yeah,
You push them on the swing sometimes, right?
yeah.
And it's like if you push them at the right time, you don't have to put that much effort in. They just keep going, right? And honestly, like you push them too much at the right time, they're gonna like fly off the swing, right? So it gets easier the more that the timing of these things is appropriate to what's happening. This is like basic positive feedback resonance kind of thing. And the same thing's happening with the sun. The seasonal changes happen, but there's more reflectivity, so there's less of the seasonal changes, and then all of a sudden you find yourself in a totally different ecosystem. You have differences in the currents of the water that result from that, which then results in different weather patterns, and like you just get this feedback amplification of things. So like it seems like a bistable system, right? In some sense, it gets to one side of the tipping point, and then these feedback systems build up, and it goes to the other side, and it just
Yeah, but the spirit behind the theory, I see axial tilt there, is that they think that there's a seasonal tilt that's changing from 23.5 that.
not seasonal, but over these enormous.
Seasonal, like
Yeah.
25,000 years or whatever.
Yeah. There's something to that, but there's also another troubling aspect about that explanation is that this isn't. So if we go, well, I don't have the right graph for you. If we look further beyond a few million years, we don't see this periodic glaciation anymore. Now, presumably, the Earth still had the axial tilt for other reasons, which we could get into. We still believe the Earth had that tilt, and a lot of these things should have remained consistent. So I'm like a little personally unsatisfied with that explanation. I don't know what the explanation is, but it does seem to be something that's been introduced relatively recently, and that's really interesting. So there's going to be a number of points in astronomy in this class, and especially next semester, where we're kind of at the edge of what we know. And so maybe somebody will come along who has a better idea of how this could work out, and they'll win out. But for certain, we know that it does happen pretty regularly, at least for the last few million years. Every 100,000 years, we get one of these climate inversions. And so I guess my bigger point is like, we have that to look forward to one way or the other. We would be wise to figure out how to adapt to it as it happens. In addition to stop poisoning our own, water supplies and everything like that. That would be good too. I would love to see a lot of EVs too, because they're quiet, and I'm really annoyed with how loud engines are. That would be great. They're less smelly. All these things are great, but we need to come up with good ways to power those things. Because just burning a bunch of stuff to power EVs is not a solution. They also generate way more tire pollution as a result of microplastics and garbage like that too. So, they're not a fix-all by themselves, and we have to think multivariably about these problems if we're actually going to make the world a better place. Questions? Thoughts? Yes.
What do you think about the climate clock?
The climate clock.
Yeah.
I don't know. It sounds like clickbait. I mean, look, people on the internet make their money by getting you to read their stories, right? I mean, I do think that this is the thing. It's like I'm absolutely an environmentalist. Like I absolutely think we gotta take care of this place. Like I want to see lots of animals when I go in the forest. I want to see lots of fish when I go swimming in the river. But at what cost to humanity are we going to be literally freezing people to death in Burma to do that? And B, what's the road? Like, how are we going to pull that off? Are we going to just say something like we're going to all drive EVs, but not think about how we're going to power them, right? Are we going to nuclear is a fantastic option, and we'll talk about this I think later. But But people are terrified of the word nuclear, right? And for good reason, because, World War II and everything, right? But the reality of the situation is like nuclear power is extremely, extremely safe compared to coal burning power plants. It's killed almost no one compared to coal burning power plants. I grew up in Ohio, and we got lots of these coal burning power plants out in the country, and it's gnarly. Like, it's really gross yellow smoke going up in the air. And people, cancer rates on the rise, all sorts of nasty stuff. There's diseases we didn't even have a problem with like 100 years ago. So what's up with that? And are we really solving the problem by just driving electrical vehicles or something like that? No. So I think we have to really reconsider some of these options. I mean, nuclear is fantastic, by the way. But then again, okay, so you have nuclear power. Now you need really good batteries. How do you make really good batteries? Well, maybe you have to have a bunch of child slaves in the Congo mining cobalt so you can make these batteries. Well, that's not a good situation either, right? So there's variable calculus going into this. All these effects have to be considered together. You can't just stare at one little variable just because you think that it sounds good at the time. We have to learn to think this way as a civilization, or it's just not going to work out for us. I mean, people are going to just walk away from it, honestly, or worse, people get mad and fight each other over red-blue stuff, or whatever, right? Things don't work out, and I don't think any of us want to see it go that way.
Have you ever heard of hydrogen powered?
Hydrogen's interesting, yeah. It's extremely flammable is the problem. But I've heard some other cool ideas too. There's a number of possible options. We had a guy on the podcast the other day who's like kind of this utopian thinker who's trying to build this city in the desert in Peru, and out of from nowhere. And he imagined actually replacing coal combustion with iron combustion, which is interesting, and using the iron as a recycling product. And then, another possibility is ammonia combustion, because you can get ammonia as a byproduct of different recycling reactions. But in terms of like a portable fuel, it's very tricky. I mean, here's an idea, guys. Why can't I take a train from where I live in Grants Pass down to work here? It's crazy. It's absolutely insane. Like, they've been doing this in Europe forever. My wife is always like, well, who's going to pay for that? I mean, we could all pay for it if we're just like, that's a good idea, probably. It's not impossible is the thing. It's tricky. We have a nice corridor. The 5 runs up there already. It's not unimaginable to do something like that. And of course, then it's like, yeah, I haven't answered the question about how we're going to power the train yet, but I can tell you it's going to be a lot cleaner than a bunch of us driving our cars back and forth, whether they're EVs or whether they're, Jeeps or whatever. So like there's known solutions to these bugs, right? Yes, please.
Sorry, it's so random.
Yeah,
Just
hit
one
me.
of these random solutions. I watched this documentary about how Bill Gates had this idea to cool nuclear rods with liquid metal. And the ones that are already used up right now, because obviously they're being cooled with water,
Mm-hmm.
they can be reused now because they can be, they're not gonna burn off the water or the liquid metal.
Interesting.
And the point was, the statistics of it was that we could have basically power for like 60 more years using the spent rods, like right now in America. And right now, they're just being like stored like really poorly.
Yeah, they just jam them in a
And
mountain
so
or
it's like
something.
we solved 2 problems. And he like even started the company and they had stock options and then it just like failed.
Yeah, that's the problem. There's like really bad public support for nuclear stuff.
People are
They're terrified of it. And it's not just people, by the way. I think that that's the one you hear a lot is like people are terrified of it. It's kind of true. The other problem is that if you there's these China is rolling out a lot of these like basically portable nuclear reactors, small modular reactors. You can power a small town with just this little like thing that basically fits on a tractor trailer truck, right?
Yeah.
They're very cheap to make. They're very safe, actually. That's not the problem. The problem is once you allow like small countries and so forth to have these things, you allow, the superpowers that be, right? Like the UN or something, or whoever the dominant superpowers are. Well, you've given them fissile nuclear materials at the same time. And people are really scared of nuclear proliferation, probably for good reason.
It's kind of valid.
So that's the question with nuclear. It's like, how do you unleash this? it's not that we can't do it cheaply. It's not that it wouldn't be the best, most clean power imaginable. It certainly would be. It's not that they blow up all the time and destroy towns. That almost never happens. Even in the worst case scenario, like Chernobyl or something, those places bounce back in no time, actually.
Yeah.
So it's not really those things. It's more just, my God, if we start handing out nuclear material to people all over the planet, will they behave themselves?
Right.
Right? And I don't know. I don't know what to think about that yet. What do you think? You think people would behave themselves, or you think they'd all just start making bombs?
I think the most dangerous is just the people that already have them.
Yeah, well, it's mainly us and Russia, China, India. There's only like 5 of us, I think.
Yeah.
But yeah, we're all pretty belligerent nations, so it's tricky. Any more thoughts about climate? Please.
Think about trains, like who's gonna pay for them?
Yes.
The road maintenance already costs a ton.
It costs a ton. It's
If
unbelievable.
you just replace some of the roads with the trains, it's not really more expensive.
I think the trick is yeah, it's like you kind of got to like break some eggs to make an omelet in some sense. So there's all these contractors that are set up to deal with that, and they're lobbying really hard to not see change with that kind of thing. It's very tricky. It's very tricky. It's very tricky for politicians in our current political climate, to do anything really radical because there's so many exterior influences that are pushing on them from all sides. But yeah, I agree. The cost seems to be negated because keeping a road running is extraordinarily expensive. God, I was looking at it the other day. I wish I had the figure off the top of my head, but it was mind bending. It was like millions of dollars per mile. It was something crazy like that per year. Very, very, very expensive because you got to repave these things all the time. The engineering that goes into it, the labor costs, it's unbelievable. So yeah, I don't know. They're trying to put a high-speed rail through California right now, and they're running into like all this NIMBYism with it, right? Where people don't want the rail going through their farm or through their backyard, whatever it is. So that's a real problem too. I don't think that's his problem up here in Oregon because there's just a lot of more public land, and like we have these corridors, like the 5 that are already in place. And man, it would be a beautiful world if we could ride a train between at least these 3 cities, right? It's not even that much train lines, like about 20, 30 miles or something like that. That would be really beautiful. I have to think more about that, like what it would take to make that happen. I think somebody would have to basically dedicate their life to it, but I think it could happen. So there's like all these little tiny little decision things that we make all the time, right? And oftentimes, yeah, somebody's got to sort of nail themselves to the cross to get it done, but it could happen. Any more thoughts? So here's an interesting idea too. This is more food for thought. I don't know what it means. So this is what every summer and every winter, every year, this is what happens with our North Pole, right? You can see it gets quite big in terms of like the snow cover, right? This is what it would ostensibly look like from outer space if you were just parked at the North Pole, right? Pretty predictable. Most importantly, this cycling that happens every year is centered on the poles, right? Depending on which side you're at, it's going to be inverted. But there's something very peculiar about that glaciation cycle, that climate cycle, which is that it was actually not centered on the pole. Now, this is really, really bizarre, and I have no idea what this means exactly or what it says about the cause of the glaciation cycles, but the last glacier was actually centered on Greenland, which is very bizarre. It was actually temperate in Siberia. They find these woolly mammoths and stuff who had these like summertime buttercups and stuff in their stomachs during the last glaciation cycle. So Siberia was nice, and there's a huge glacier centered over Greenland, which is actually south of the North Pole by quite a few clicks. So what does that mean? I have no idea. And you can see a really nice indentation of this, by the way, if you look at the topology on Google Maps or something, you can see where that glacier came down. And it is definitely centered over Greenland and Canada. It is not centered over the North Pole. Now, whether that was something that happens every time that it's not centered over the North Pole, I don't know. But if it was, maybe it speaks to some other explanation for what's going on with this periodic glaciation stuff that seems to be quite regular, and why it appeared suddenly a few million years ago as opposed to being something that's always been a feature of Earth. It's very, very bizarre. By the way, my friend who's a geologist in Utah made these images, which are really cool. His name's, oh God, I'm slipping his last name. His name's Lance. Cool guy. Anyways, all right, so that brings us through essentially the end of week 3. We're actually in week 4 now. And this week, like I said, I really want to talk about calendars. I want to talk about eclipses and the moon, the origin of the moon. That's an interesting question. A little bit up for grabs still. And then we're going to talk about light itself, which is one of my favorite topics because it's ever present in our lives and nobody understands what the heck it is. So, by degrees, I should say. No, people by degrees don't understand it. What's up with calendars? So this gets into some interesting territory. So we define the day. The day is pretty easy to define, although whether it's the sidereal day or it's whether we measure our return to the start by the stars or by the sun is a little different. But generally speaking, we measure it by the sun because that's more useful to us. The problem is that the period of the revolution of the Earth, the year, is actually 365.2422 days, right? So I said at the beginning of class. So making a calendar that's exactly precise like that is extremely difficult to pull off. And people have made many different attempts at it over the years. So, very famous example. Anybody ever been to Stonehenge before? All right, you should go check it out. They're actually building a freeway underneath it right now. You been? Okay. There's some big mound structures out there for sure. They found one at the bottom of Lake Michigan, I think, recently too. Some sort of stone circle. Pretty crazy. Yeah, they're finding these things all the time. So it seems like our ancestors everywhere were really into building these astronomically aligned some sort of quasi-calendar system. And people have done a lot of work on Stonehenge, and they've actually found that the Stonehenge people had divided up the calendar not only to show the position of the solstices, but also that they had some sort of a marker system that they would go around and mark the day of the week for each month as they did this. And they actually divided their calendar up into 3 weeks, which is a little bit different. Now, I did want to read you guys a little passage from this book. So, the textbook is always the textbooks are always saying they do these calendars because it was the birth of civilization and they were really into agriculture, right? There's problems with that. The main problem is that agriculture, as far as we can tell, the earliest signs of agriculture were, 7,000 BC, something like that. The problem is that Stonehenge people were 3,000 BC, and they weren't into agriculture at all, actually. So they were seasonal herders. And I want to maybe open your minds up to another possibility for what was going on. But I want to read you a little passage from The Dawn of Everything. This is a fantastic book by David Graeber. He says, "The people who built Stonehenge were not farmers, or not in the usual sense. They had once been, but the practice of erecting and dismantling grand monuments coincides with a period when the peoples of Britain, having adopted the Neolithic farming economy from continental Europe, appear to have turned their backs on at least one crucial aspect of it, abandoning the cultivation of cereals and returning from around 3300 BC to the collection of hazelnuts as their staple source of plant food. On the other hand, they kept hold of their domestic pigs and herds of cattle, feasting on them seasonally at nearby Durrington Walls, a prosperous town of some thousands of people, with its own wood henge in winter, but largely empty and abandoned in summer. The builders of Stonehenge seem to have been neither foragers nor herders, but something in between. All this is crucial because it's hard to imagine how giving up agriculture could have been anything but a self-conscious decision. There's no evidence that one population displaced another or that farmers were somehow overwhelmed by powerful foragers who forced them to abandon their crops. The Neolithic inhabitants of England appear to have taken the measure of cereal farming and collectively decided that they preferred to live another way. How could such a decision have been made? We'll never know, but Stonehenge itself provides something of a hint since it's built of extremely large stones, some of which, the blue stones, were transported from as far away as Wales, while many of the cattle and pigs consumed at Durrington Walls were laboriously herded there from other distant locations. In other words, and remarkable as it may seem, even in the 3rd millennium BC, coordination of some sort was clearly possible across large parts of the British Isles. If Stonehenge was a shrine to exalted founders of a ruling clan, as some archaeologists now argue, it seems likely that members of their lineage claimed significant, even cosmic roles by virtue of their involvement in such events. On the other hand, patterns of seasonal aggregation and dispersal raise another question. If there were kings and queens at Stonehenge, exactly what sort of kings and queens could they have been? After all, these would have been kings whose courts and kingdoms existed only for a few months of the year and otherwise dispersed into small communities of nut gatherers and stock herders. If they possessed the means to marshal labor, pile up food resources, and provender armies of year-round retainers, what sort of royalty would consciously elect not to do so? Which is really, really interesting. So what he's trying to say here is this story that we have of this nice arc of civilization from, tribes to agriculture to hierarchical society with vast inequality doesn't seem to have played out in the archaeological record. And he has lots of examples in this book, but he's talking about Stonehenge here. And he's like, they actually had this biannual system where half the year they would get together and act like a cohesive society with this hierarchical structure, and then they would completely disband and form a completely new structure every year in the seasonal fashion, arguing in some sense that the calendar system was central to structuring their way of life, which was not the same as our world where you have a government all the time, but instead you would put that together once a year, presumably with completely different people.
I feel like I remember hearing one of the theories that Stone and Women were part of like a ritual that they did every year.
Definitely.
And between the two, I think there's a river, and they'd walk along the river, and Stonehenge, in the theory, symbolized death, and Women symbolized life.
Cool.
Wood is like more living, stone. And it was this ritual that they would carry walking back and forth, and whether like Stonehenge lighting up with the solstices and stuff is also part of that ritual, and it'd be like, I think if anyone that in the civilization past, they'd have that ritual and they would hold it there. I don't remember it fully, but it was the ritual of walking back and forth and the symbolism of lighting that. Really cool.
Yeah, and I think of like reconvening too. I think that's what he's hinting at here is just that they didn't quite have they didn't really fit into any of these models of this like simple like progressive narrative that we have of how civilizations come and form. They lived part of the year in dispersed tribal format, let's say, and they came together with enough hierarchical organization to be able to move incredibly large stones across vast distances and create these structures. And then of course they had the seasonal ceremonies and all of this. So they had the ability to completely disband their hierarchical government once a year for half the year while they all went and did other things. That's really weird. It doesn't fit into our nice, pretty picture of the arc of progress, right? And I think that there's so much of that going on. And when we look at these calendar systems in general, like when we look at the Mayan calendar structure, it doesn't make any sense based on agriculture. It has no bearing on the solar year, but it was deeply important to the layout of their culture, which we don't really understand to this day. But at least with Stonehenge, it seems like something else was going on. It was not the kind of civilization that we have today. It also wasn't some primitive tribal situation either, like a lot of the sociological, anthropological textbooks would have you believe. It's something weirder. It's something more conscious and planned out. They had a different groove, right? We were talking about rhythms of society earlier, right? They came up with a different groove, a very creative one. And it's hard to say how much, when we look at these old civilizations, what the heck was going on. There's also this I have a hard time saying this one, Göbekli Tepe, right? You guys have heard of this maybe? Really, really old, like 9,000 BC, I think. Like stone monuments and structures and city-like entities in, I think it's near Armenia in Turkey. And they didn't have agriculture at all, right? The standard archaeological narrative is like this was kind of a crossroads of hunter-gatherers who sort of got together. But it's like kind of hard to imagine that in some sense, right? That you would be able to marshal the labor to build enormous megalithic structures while just being some loose affiliation of herders or something, or hunter-gatherers, right? There's something more complex going on there that is kind of beyond our imagination in our current civilization paradigm, where everybody fits into a nice little groove. Like, you guys are students, that's what you do, is do student stuff 100% of the time. You know, maybe you'll go and work at a company and you'll be a company person 100% of the time. I don't think it was that simple back then. I think there was a lot of different grooves that people tried out, and they did it very consciously. It wasn't some lowest energy configuration that people just fell into. And that's a remarkable paradigm shift that's happening with respect to all these ideas about what the calendars meant. You know, I don't think that it was as simple as just being about agriculture, because a lot of these people weren't agriculture in nature. That's really the bottom line. So why did they care so much about the seasons? Maybe it had to do with the way that they organized their governments, they organized their structures. They knew when it was time to take on the new role that they had, right? It's time to stop being a student and be a stone mover, whatever it is, or a high priest or whatever. Thoughts? All right. So the Maya, this is a picture of, you know, it's kind of often referred to as an observatory. This is at Chichen Itza. I got to go there when I was a little kid, which was awesome. You know, this one actually, this little pole up here, I guess, was for sighting Venus. There's some very important alignments of Venus that they were fascinated by. So we'll talk, when we get to Venus, we'll talk a bit more about Mayan mythology with respect to Venus. But they were obsessed with Venus. They couldn't really care less about the sun. It was all about Venus for them. Now, Venus does this really, and the Babylonians too, the Sumerians were really obsessed with Venus, as it turns out. Venus is weird. It is a star, ostensibly. It looks like a star. You'd probably think it's a star if nobody's told you otherwise. Except that, of course, it's in different places each night, which is not what stars do for the most part. So why is that? Well, they didn't know why, but they knew that for about 250 days of the year that it rose in the morning, and for another 250 days it rose in the evening, which is really weird, and then it disappeared in the meantime. Now today, of course, we realize it's on one side of the sun, and then it goes in front of the sun and you can't see it, and then it goes on the other side of the sun, and then it goes behind the sun. And so a lot of the mythology, if you look at the mythology from the Mayan civilization, and a lot of these Mesoamerican civilizations, it has to do, and the Sumerians for that matter, it has to do with this descent into the underworld and this entire meta story of, you know, this rising entity, some sort of deity who's getting shot down and getting forced to go on this quest through the underworld, which you see in like all of mythology, right? It appears in like the Christian Bible as the story of Lucifer, right? Actually, the word Lucifer refers to the morning star, which is of course Venus in the sky. And so you have this angel that tries to like make himself brighter than the sun, well, brighter than God or brighter than the sun or whatever, and gets shot down, right? And goes into the underworld. And this is a really common trope that appears over and over again in mythology. So Mayans are obsessed with Venus. Now, their calendar, see if this movie will play. Their calendar is really bizarre. So it has these 3 interlocking cycles where they have these 20 different names for these days, 13 numbers. It repeats every 52 years. This is the main cycle. But it also fits into this even longer cycle, which lasts for 5,128 days. And you guys may have, I don't know if you guys are too young for this, but back in 2012, the most recent cycle was scheduled to end. And the Mayans speak in terms of creation. So each one of these cycles is a new creation of civilization, essentially. And so people were, you know, losing their minds that the world was going to end in 2012. And of course, I don't know if it did or didn't, actually. Jury's still out on that one. But it was a completely bizarre calendar system by our standards because it really bore no relationship to the year or the moon or any of the things that we're used to trying to construct cycles out of. So it's very bizarre. It also started August 11th, 3114 BC. and nobody can really piece together why in the world they started their calendar on that day. I've heard everything from there might have been like a transient like supernova in the sky or some sort of cosmic event. It's very, very difficult to figure out this Mayan calendar because it's so different from ours. Now, the one that we're familiar with started essentially with the Julian calendar. This is worth remembering. So this was set up by Caesar because people were all on different calendars and it was a nightmare, and he wanted to coordinate this amongst his enormous empire. Remember, Caesar became essentially made him. They had something resembling a democracy in Rome for many centuries. Caesar put an end to that by making himself king, essentially on the back of having eradicated the Celts up north. Now, what's really interesting is that they were smart about this calendar. So he realized that the year was a bit longer than 365 days. And he approximated the year at 365 and a quarter day, which is really close. Remember, it's 0.2422, so not quite 0.25. And this worked out. So the Romans decided that the way they would do this is they would have 365 days a year, and then every fourth year they would have an extra day to account for that quarter piece. And this worked out for a while until, like I said, around 1582, that added essentially 11 minutes per year, just kept accumulating because it's not exactly a quarter, right? So what happened was that the spring equinox was occurring too early. Everything was completely offset. And so Pope Gregory the 13th, this was in Galileo's day, decided to fix this thing. And what he did was he just threw away 10 days out of the calendar, which brought the spring equinox back on track. And so October 4th, 1582, all of a sudden just became October 15th. That's pretty funny if you think about it. It's like all of a sudden you're just 11 days older. So the new leap year rules were also instated at that time. This is very close to the calendar that we have today. So the way that it works with leap years is that only centuries divisible by 400 become leap years. So 1700, 1800, and 1900 are all divisible by 4, but not by 400. So they're not leap years in the Gregorian calendar. On the other hand, like 1600 and the year 2000 are both divisible by 400, so they get leap years. So this gets us a lot closer. The average length in our Gregorian calendar, 365.2425 mean solar days. It's correct to about 1 day and 3,300 years. We actually didn't adopt this one until the 1700s, and that was a nightmare too because I think we were off by several months at that point. This was the story I was relating at the beginning. The Russians didn't adopt it until the Bolshevik Revolution in the 20th century. So this is a pretty modern invention, actually, that we use this system. And it's still a little haphazard and bizarre if you think about it, because you just kind of have to throw a day in there every once in a while. Thoughts, questions, concerns? Okay. I want to talk about the moon next, because it's the easiest thing to see in the sky, and it seems to be important to everything that's going on here. Obviously, for most of history, people thought of the moon as some sort of deity. I don't know if they literally thought about it as a deity, but it certainly symbolized that to them. It seems like nobody really proposed a material explanation for what the moon was until this dude named Anaxagoras. This was in 428 BC in Greece. He's an interesting guy. He had a number of really interesting ideas. In addition to the idea that he thought that the moon was a rock, a big spherical rock that was illuminated by the sun, he also thought the same thing about the sun. And he was the first person to give a correct explanation for an eclipse as the result of it, which we're going to talk about here in a little bit. Obviously, eclipses being when the moon gets in front of the sun, like we were talking about at the beginning of class. He also came up with this idea that life itself must have come from somewhere else, because he didn't think that life just happened all by itself, which was a really radical idea in the day. In fact, that idea that life couldn't just spontaneously generate wasn't really proved out until a couple hundred years ago, when some guy had the clever idea of putting a lid on a jar essentially and showing that things couldn't get in, so therefore you wouldn't get growth inside of the jar. So he had this idea that life came from somewhere else. Have you guys ever heard this before? It's called panspermia, right? There's this like fundamental crux of biology. This is really fun to like pick on biologists with this, which is like the first rule of biology is that all life comes from other life, right? You can't just, have like a baby appear on your counter one day, right? It's like they come from other life forms, right? However, how do you explain how life got on Earth in the first place? Because the most popular approach to explaining how life got on Earth in the first place is that life came out of non-living stuff here on Earth, right? And that's a huge philosophical dissonance, right? Because on one hand, you're saying life never comes from anything other than life, except for that one time that it did, right? Which is a nightmare. And so there's a lot of people, not a lot, but there's always been a minority of scientists and thinkers and philosophers who have said, I'm not buying that, it must have come from somewhere else, right? And so this guy Anaxagoras was one of the first people to introduce this panspermic idea. And there's a lot of support for that idea too. There's these little things, so bacteria and some fungi make these little things called spores, right? And they're really tough. Like you can literally stick them in a box on the outside of a spaceship, fly them into outer space, get exposed to all the nasty radiation and stuff, bring them back, and they'll still germinate. They found spores in the bellies of these little bees that are in amber that's 25 million years old, and they put them in a petri dish and they come back to life. They've just been sleeping for 25 million years, right? So they're really, really tough forms of life that seem like they could survive inside of an asteroid or something like that. Now, in some sense, that kicks the origins of life problem down. It's like kicking the can, right? Like, well, okay, it came from another planet in some distant galaxy or some distant solar system. But how did it get there? And like, has it just always been in the universe? Like, what's going on? So it's a real problem, and the origins of life research has always struggled to provide a mechanism for how that can happen. But we'll have a lecture on that. I'm actually going to bring my wife in to talk to you guys about that. She's a much better biologist than me. But it's a really fun debate because in some sense, like I said, life does not come from other life except for that one time that it did. Pretty weird stuff. Anyways, so this guy proposes this. He's not taken seriously. All across the globe, people are playing with this idea. It looks like around the same time there was an Indian astronomer in the subcontinent India named Aryabhata, who mentions in one of his pieces of writing that reflected sunlight is what causes the moon to glow. So that was rather prescient too at the time. People played with this idea in the let's say in the Common Era, particularly in Persia. There were some astronomers who also did various close-up estimations of the moon, measured its diameter, things like that. But generally speaking, people were just like, it's a deity, don't worry about it. So nobody really started to take this extremely seriously until our friend Galileo started making these drawings of it with his telescope, actually. And he started to see that there was actually terrain on the thing, right? Which is kind of mind-bending, because you can see this with the naked eye, right? But I also, it's hard for us to unlearn what we've been taught since we were 5 years old. So it's hard to look at the moon and not see anything other than this. But for whatever reason, people weren't really, by and large, buying it until Galileo, who really started to describe it as something much like a planet for the first time, which is pretty fascinating. They're also pretty decent drawings, if you ask me. Robert Hooke also made some incredible detailed observations with a telescope. We'll talk about Hooke some more later. I mean, there's a really interesting feature of cognitive bias in general, which is like how easy it is to believe something if you're just used to assuming it's the case, even though you look at it over and over and over again. There's some really, really fascinating studies with this. Have you guys heard of the gorilla study with the elevator and stuff, or the basketballs? Anybody? There's this really famous study. I can't remember what university this is at, but this psychologist set up this study where he brings in students and he's like, all right, he plays them a video of people playing basketball. He's like, I want you to count how many times the white team passes the ball. There's a white and a black team. And so, most of them counted and everything. And then once it's done, he acts like they're scoring it and stuff. And then he's like, All right, now tell me how many of you guys noticed like the guy in the gorilla suit walk through the middle of the movie, right? And like nobody noticed it. I think it was like less than 30%. Yeah. Was it? Oh, you're studying this. Okay. So a lot of people missed it, I guess is the better way of putting it. I didn't mean to exaggerate this, but so half the people didn't notice it, which is crazy. There's another really funny study too. Maybe you guys talked about this one, where I think this one was on the East Coast at one of these old Ivy League schools, and they would basically they set up this drama where when you go to look at colleges or whatever, sometimes there'll be, or like you guys probably see this, people come in the, I don't know, they come in the spring to look at colleges or in the fall. Anyways, they go around and sometimes they'll get lost and they'll be like, where's the library at or something. And so they basically had people pose as students who would be giving directions on these visiting weekends, right? So they'd have a map or something. And the people would come up to them and ask them for directions, like the actual visiting people. And what they would do is while they were like looking at the map and like about to show these people where the library was located at or something, they would have somebody come by, two students who were like part of the study would come by with like a chalkboard or like I don't remember what, like a door or something, and they would get in between the people, right? And while they were in between them, like kind of rudely, the person who was showing them where they were on the map would be swapped out for a totally different person, right? And again, I don't know the statistics, but like some very, very large percentage of people would not notice that it was a new person explaining to them where the library was located at after the sort of interruption had happened. So the point is that we have a really hard time paying attention to variables that are outside of our present problem-solving strategy, right? And I think that's probably what played out with a lot of this moon business as well. So it wasn't until 1834 that people realized that not only was the moon a planetoid-looking thing, a whole world, but that it didn't really seem to have much going on it. So people had hopes that it would have life forms and water and oceans and all of that, because it does have dark spots on it, right? It wasn't until 1834 that these two gentlemen, Wilhelm Beer and Johann Madler, actually published this convincing book, which firmly established that there was no bodies of water, no appreciable atmosphere, and nobody hanging out on the moon, sadly. Not that long ago. The Russians were actually the first people to go there. They didn't go there as people, but they went there with this little orbiter thing, and they took some pictures of the surface. This was Luna 9, so they tried many times before this, it seems. Didn't work out. This also brings up an interesting question, too, like what's the difference between a moon and a planet? And your textbook lists a couple of attributes. One of the attributes is that, it's tidally locked. We talked about this, I think, the first class, maybe. One side of it seems to always be facing the planet that it's orbiting. The other quality is that it has sufficient mass for its self-gravity to overcome the rigid forces so that it assumes a hydrostatic equilibrium. That's a mouthful. What it means is that it's round, right? So it's big enough that any deformations that would happen are overcome by its own self-gravity. Now, there's some problems with that definition, too, because we have a couple of bodies, like in the asteroid belt, like Ceres, for instance, right, that are round, but they're not big enough to be rounded by gravity. And it's very confusing as to what the heck that thing is and how it got to be that the way that it is. And we'll talk about that. We have a little class devoted to the asteroid belt. But it's very difficult to define what a moon is. But for now, we'll just say it orbits a planet. It's actually really difficult to say what a planet is, too, unfortunately. Yes? You're good.
So you know how this is spinning? Is this an estimation of what the other side of the moon would look like, or do we know that is what it looks like? How we take it in?
Yeah, we've orbited it quite a bit. And there's actually like a static satellite parked over there, too. But yeah, we've been around it a bunch, at least remotely. And then, of course, the whole Apollo business as well. Anybody think we haven't been to the moon in this class? Like humans on the moon? Nobody?
I used to think that was like complete baloney. and
Yeah,
There's at least some credence to evidence. Maybe it was like they faked it at first and went there later. I don't know.
I don't know either. But the story is that we did. But we've certainly been there remotely. That seems to be the case. There's plenty of reason to believe that we've visited in many different ways. There's plenty of satellites that you can look at. There's retroreflectors placed on it. But yeah, that's an interesting question there. We don't actually have time to do all the different spaceflight in this class. It's unfortunate. I always thought it'd be really fun to have a class here that was maybe like an upper level seminar where we went through the history of spaceflight, because there's so many details to it. There was, of course, this huge, during the Apollo program, which is when we put men on the moon, there was this enormous international struggle between the Soviet Union and the United States, huge race to see who could do it first, all sorts of spooky CIA shenanigans going on. It's really a huge conversation. It's too big for this class, so I'm not going to do it. Plus, we'll probably piss somebody off. So, planets. Like, planets are really difficult to define, too. Oh, man, you guys, it's over. I'm sorry. I didn't notice. I hear people packing up. All right, we'll pick up here. We'll talk about this planet-moon boundary next time. Have a good rest of your week. See you Thursday.